Hey everybody, Mr. Brown here, and in today's video we are going to be predicting double replacement reactions. To predict double replacement reactions, we need to have some background in ionic compound solubility, so we're going to take a look at those first. Here we have two ionic compound solubility tables. The one on the left is the table from the OpenStax text, and the table on the right is a different style of ionic compound solubility chart that is from Flynn Scientific Supply Company. I really like this one, and I use this one a lot in lab myself, so that's why I decided to include it here, just to show you two different styles of this chart. And I want to show you guys how this works. We are looking at the one on the left here, just as an example. If I wanted to know, for instance, if magnesium carbonate was soluble or insoluble in aqueous solution. So the way the chart, this chart on the left here works from the OpenStax text, what you want to do is find one of the ions, either one of the ions, as part of that compound, and then try to check and see is it on the soluble side or the insoluble side of this chart. So we want to know, the question is whether or not MgCO3, that is the formula for magnesium carbonate, we want to know whether or not magnesium carbonate is soluble in aqueous solution. So using this table, I may start to filter down through the ions that are listed until I run into either the magnesium ion or the carbonate ion, and kind of seeing where that falls on the chart. So as I kind of filter down through here, I see ammonium, lithium, no magnesium or carbonate yet. Moving down through the soluble ionic compounds, I still don't see any magnesium or carbonate yet. Still have yet to see any. And there, the first one I arrive at, I do see that the carbonate ion is listed on this table. It is listed as an insoluble ionic compound. So what that means is any ionic compound containing carbonate is going to be insoluble unless it is one of the exceptions listed in the third column of the table. The exceptions for the carbonates are compounds with group 1 cations and the ammonium cation. Magnesium is neither of those things. It is a group 2 cation, and it is certainly not ammonium. So that would mean that any compound containing carbonate and magnesium, or magnesium carbonate, is going to be insoluble. To use the Flynn Scientific Solubility Table, you do the same thing. You find the particular or a particular ion of interest from the compound. So looking down the anions on the left side here are the carbonate ions. And then you find on the top, we see our cations. We find the cation that we're working with, magnesium 2+. And you see where those two intersect. And in the box where those two intersect, we see that this is also listed as an insoluble compound. So both showing that this is an insoluble ionic compound. That's how you use the solubility charts. If we're moving along, so now that we can predict whether an ionic compound is soluble or insoluble, we can now have a discussion about a specific type of chemical reaction called a double replacement reaction. If you take two aqueous solutions of soluble ionic compounds, we have our example here. In beaker 1, I have a solution of silver fluoride, the formula AgF. And when I dissolve silver fluoride in water, I separate the ions, and so I have an aqueous solution containing Ag plus ions and F minus ions. In beaker number 2, I have a solution of potassium chloride. When I dissolve potassium chloride in water, I get a solution of potassium 1+ ions and chlorine 1- ions. Now, if I pour those two aqueous solutions together, the ions will try to switch places. The cations from one compound will try to switch and bond with the anions from the other compound. So silver will try to make a combination with chlorine, and vice versa. Potassium will try to make a combination with fluoride. This reaction will take place if either of those combinations results in an insoluble ionic compound. We can see in this particular example here that if we look at the ionic compound that's formed from silver and chlorine, that is silver chloride, and if we check our solubility charts, silver chloride is an insoluble compound. So this double replacement reaction will take place. If we pour these two solutions together, we will see the precipitation of solid silver chloride from our aqueous solution. Now the other combination, potassium fluoride, is a soluble ionic compound. So it will stay dissolved in the aqueous solution. In fact, it will stay as free potassium and fluoride ions in that aqueous solution. But we will see a solid precipitate out. That silver chloride would drop to the bottom of our aqueous solution as a solid because silver chloride is insoluble. So double replacement reactions happen when you pour two aqueous solutions of different ionic compounds together. The ions try to switch places and a reaction occurs if one of the products of the switch is an insoluble ionic compound. Here we're going to do an example, try to predict the possibility and result of a double replacement reaction. The problem here asks, if aqueous solutions of lead 2 nitrate and ammonium carbonate are mixed together, predict whether a chemical reaction will take place and what the products are if so. Write a balanced chemical reaction for the process. So the first thing we have to do is figure out what the formulas of our compounds are. Lead 2 nitrate will have the formula PbNO3 2 plus the second compound we're told there, and we're told we have these in aqueous solution. We'll go ahead and put the AQ there, plus ammonium carbonate. Ammonium is NH4 with a 1 plus charge, and carbonate is CO3 minus, or CO3 with a 2 minus charge. So the correct formula for ammonium carbonate is NH4 2CO3. Now, we know that in a double replacement reaction, each of these ions are going to try to switch places. So that would lead to the formation, if this happens, that would lead to the formation of, I have to put the aqueous there, that would lead to the formation of lead carbonate, lead 2 carbonate specifically, and ammonium nitrate. So it's up to me to figure out what the formulas for those compounds are. You cannot just switch the ions and bring their respective subscripts over to the product side of this reaction. You must balance the charges and give correct chemical formulas for all species involved. So when lead 2 bonds with carbonate, which has a 2 minus charge, you only need one of each ion. So the correct formula for lead carbonate is PbCO3. We'll hold off in checking the solubility until we have both of our species. The other combination would be the combination between the ammonium cation and the nitrate anion. Both of those carry a 1 charge. Ammonium carries a positive 1 charge and nitrate carries a negative 1 charge. So the correct formula is just one of each ion, NH4NO3. Now we may want to stop here and go and check and see if either of these are insoluble products. So I want to check first. I see lead carbonate, so I may start with lead carbonate. I look at my solubility table and I try to find either one of these ions, a lead 2 ion or a carbonate ion. The first one I see is the carbonate ion, and I know that any carbonate that's not bonded with a group 1 metal or ammonium is insoluble. So this would in fact be a solid, and that would be our precipitate from this double replacement reaction. For posterity, we'll definitely check the solubility characteristics of ammonium nitrate, and I can find nitrates in the solubility, or rather the soluble part of the chart, and no exceptions to that rule. So all nitrates are soluble. This would stay dissolved, and this would be symbolized with the AQ to show this in aqueous solution. Now the last step is to balance this chemical formula, and you would arrive at the fact that you put a 2 here, and that should balance this chemical reaction. Here in our second example, we read, if aqueous solutions of magnesium sulfate and sodium carbonate are mixed together, predict whether a chemical reaction will take place and what the products are if so. Write a balanced chemical reaction for the process. So again, we start by getting the correct chemical formulas for these compounds. Magnesium is a 2+ cation based on its position in the periodic table. Sulfate is a 2- polyatomic anion with a 2- charge and the formula SO4. So the formula for magnesium sulfate is therefore MgSO4. That is soluble in water as it's in aqueous solution, so we will write AQ. Sodium carbonate. Sodium is a +1 cation, and carbonate is a CO3 2- polyatomic ion. The formula for sodium carbonate therefore becomes Na2CO3. It is also dissolved in water, so it is shown as aqueous solution. Now if we mix those ions up in the double replacement reaction style, sodium would bond with sulfate and magnesium would bond with carbonate. We should try to figure out what the correct chemical formulas for those combinations are. Magnesium has a +2 charge. CO3 has a -2 charge. So the formula for magnesium carbonate is MgCO3. Plus, sodium always has a +1 charge, and sulfate has a 2- charge. So the formula for sodium sulfate is Na2SO4. Now, of course, we want to go and check and see if any of these forms solid or insoluble products. Starting with carbonate, I see that carbonate is part of the insoluble ionic compounds as long as it is not bonded with group 1 cations or ammonium, of which magnesium is neither. So that will form a solid insoluble compound. Sodium sulfate, if I look for the sodium ion, I find it first, and I see that all sodium containing compounds are soluble, so this would stay dissolved in aqueous solution. I want to make sure this equation is balanced, and if I go through, I see 1 magnesium atom on either side, 1 sulfur atom on either side, 7 oxygen atoms on either side, and 2 sodium atoms on either side. So this equation is already balanced without any coefficients, so this would be the correct double replacement reaction for the reaction between magnesium sulfate and sodium carbonate. Here in this last example, we read, if aqueous solutions of sodium hydroxide and potassium chloride are mixed together, predict whether a chemical reaction will take place and what the products are if so. Write a balanced chemical reaction for the process. The formula for sodium hydroxide is NaOH. So I need to write NaOH, and it is in aqueous solution. Plus KCl is the formula for potassium chloride. It is also in aqueous solution. So in the double replacement style, if I mix those ions up and put cation A with anion B and vice versa, the results of that mixing would be sodium chloride. Hopefully we know the formula for sodium chloride is NaCl, and it is a very soluble substance, so we will put AQ there. The result of the other mixing will be potassium hydroxide. Potassium hydroxide will have the formula KOH. And if we look through our solubility rules, we find the hydroxide ion is soluble as long as it compounds with group 1 cations. Well, potassium is a group 1 cation, so both of these are soluble products. And we would actually list this reaction as no reaction because everything would stay dissolved and we would just simply be left with a solution of all of these different ions. So if we did mix these together, we would be left with a beaker of water, and inside that water, or dissolved in that water, we would have some Na pluses, and we would have some K pluses, and we would have some OH minuses, and we would have some Cl minuses. And everybody would be living in grand harmony, no precipitation, no reaction happening. So that's just a short course on double replacement reactions. I hope that helps you understand and answer the assignment. And good luck with double replacement reactions.